Alright, so in this video clip, I'm going to demonstrate how to optimize regression complexity. So remember that, we just created by using a stepwise selection method, we created a sequence of models up to when the modular complexity is 8. So from step 1 to step 8, at each given step, we know which combination of inputs can lead us the best possible results in terms of their statistical significance. But now, what we are going to do is, within this sequence of models, we're gonna select the one which is the best, which produces the best result. What I mean by best is which can provide the minimum misclassification rates when assessed on a validation set, or the model with the least average square errors when assessed on a validation set. So to do that, I'm going to select View, Model, and select Iteration Plot. This is similar to the subtree assessment plot we saw from decision tree results, but within regression, module, it's named differently. It says Iteration Plot. And if I maximize this, y-axis is similar as before. Either it displays average square errors or the misclassification rates. So let me switch to misclassification rates. And x-axis, the model selection step number. So this is consistent with the step 1, step 2, all the way to step 8 you saw from the stepwise regression result. So the max is set to be 8, and it shows what happened on the misclassification rates when a particular model with just one input, a model with 2 inputs, 3 inputs, when it is evaluated on validation set. And by looking at this, you can see that this is where you can minimize the misclassification rates on a validation data set. So amongst 8 possible models with 1 input, 2 inputs, 3 inputs, all the way to 8 inputs, you actually have to select a model with only 3 inputs in order to minimize misclassification rates. That's the result you can draw by looking at this iteration plot. So let me exit this window, results window, entirely. And remember, in our earlier regression, the model, the sequence of models reached to number 8, only 8 different sort of combinations. 1 input, 2 inputs, all the way to 8 inputs, a model with 8 inputs. But we'd like to evaluate even a large sequence of regression models. So to do that, we have make some adjustments in our properties panel. So let's go to Use Selection Default. It is under Model Selection, Use Selection Default. We're gonna change it to No. And we will actually specify our own. So right below it, there's a selection options. Hit the small box and change the value for entry significance level from 0.05 to 1. The implication from this change is that basically we will give every single input existing in our input list a chance to enter the model. So we basically lower the bar so that at least every single input in the data set has a chance to be considered to enter the model. So that helps us to sort of enlarge or increase the potential pool or the sequence of models we can possibly explore. By the same token, I'm going to increase the value for stay significance level from 0.05 to 0.5. So, meaning that once an input enters the model, it can actually stay longer by lowering this bar. Even if it's not hugely or highly statistically significant, it can still stay in the model. So that's the impact. Last change I'm going to make is the maximum number of steps. I'm going to just say 30. Just limit the maximum number of steps, limiting the size of sequence up to 3. And with that, select OK and run the model. So by making this change, we can expect that the x-axis, previously the maximal value was like 8. The maximal number of steps was selected to be 8. But now by lowering the bar for any input to enter the model and stay in the model, we can expect the highest value on the x-axis should be higher than 8, 15 or 20. So which means that we evaluate even a larger sequence of regression models, not to miss an optimal model. So let's see what happens. So here is the results. I'm going to hit View, Model, and the iteration plot. So on the x-axis, now Enterprise Miner selected a larger sequence of regression models, up to a model with 18 inputs. And if I change the assessment measure to misclassification weights, look at the red plot, it does minimize misclassification weights when only 3 inputs enter the regression model. But by looking at this in a longer tail, you can be more confident since you evaluated a larger sequence. I mean, this is indeed the optimal one. Right? That's the benefit of evaluating a large sequence by lowering the bar, by changing the entry and exit, the cutoff values as we did. Okay.